Welcome to another talk on machine translation. In the past, we have covered the very shallow phrase-based model, as well as two types of trees to represent the grammatical structure of the sentence. This time, we're going to delve deeper and describe a system that transfers at the deep syntactic representation of the sentence. Linguistic theories describing some form of grammatical structure or correctness of sentences have been around for thousands of years, building upon ancient approaches like the Panini grammar or more recent works by Lucien Tenier. Dependency grammar seems particularly well fit for representing the meaning of the sentence. A number of linguistic theories that approach the sentence in a step-by-step or stratified manner got formalized in the 60s of the 20th century. One of those is the meaning text theory by Igor Melchuk, and another one is the Functional Generative Description by Professor Petr Zgal and his colleagues. The FGD theory stems from the Prague Linguistic Circle, a group of linguists active between World War I and World War II in the Czechoslovakia. Stratified theories encompass almost the full ensemble of linguistic subfields. Utterances, written or spoken, are gradually analyzed at the various layers of linguistic description, and each of the layers is assumed to obey a certain set of rules, written or designed to be as much independent of the surrounding layers as possible. Other sets of rules govern the relationships between the layers. To deserve its name, computational linguistics did not stop at some vague description of these rules. In fact, the rules were written down as formal procedures, almost complete programs for push-down automata, a restricted type of Turing machines. Later, it turned out that writing these programs is extremely difficult, and that it is also very difficult to check whether they do what they're supposed to do. So the effort was moved to treebanking, manually analyzing many sentences at the various layers of description. In the framework of FGD, the treebank is called the Prague Dependency Treebank, and since its first release in 2001, 3 versions have been already published. The documentation of the Prague Dependency Treebank version 2 includes a nice overview. So we learn that the layers here are called tectogrammatic or T layer, the deep syntax of the sentence, and analytical or A layer, the surface syntax of the sentence. Further layers correspond to the sentence as it is written in words. So we see that the A layer has one node for every word in the sentence. On the other hand, the deep syntax of the sentence, the tectogrammatic layer, represents only content words as nodes, and all the auxiliaries, such as prepositions or various particles of the verbs, are contracted and hidden. They are represented only as attributes within those nodes. So the deep syntactic representation is kind of predicate argument structure. We know what is happening, the event, and what are the participants of that event. The various theories differ wildly in many details of the analysis, as computer programs do even when they were designed to do the same job. The theories also differ in focus on different things. For example, the meaning text theory puts a certain emphasis on lexical functions. Here we have an intensifier, the lexical function megan, and that captures the fact that different nouns need different adjectives to express larger magnitude. Tall man, high building, and a great success. The functional generative description in its tectogrammatic layer includes a component on information structure, or the topic focus articulation. That is, distinguishing that some parts of the sentence bring new information while some parts relate to an older and known information. Another prominent aspect of the tectogrammatic layer is the Valency Theory. The Valency Theory describes the fact that some words need to be complemented by other elements in the sentence for the sentence to be complete. A good theory needs some form of validation, and for Valency Theory in FGD, this is the Valency dictionaries. One of these dictionaries, Valex, is actually printed as a book, but in contrast to standard dictionaries, this was actually first an XML file to be read by the computer, and only then printed. With this dictionary, we or the computer can formally check whether nothing is missing in the sentence. So for example, the Czech verb to translate, překládat, needs to be complemented by someone who is translating, some content that is being translated, some source language, which has the preposition z, and some target language, which has the preposition do. Such a complex and linguistically adequate analysis, however, comes at a price. These are the 1,000+ pages for the tectogrammatical description of Czech, and this is the 200 short version of English annotation manual. With so much effort put into the design of the theories, and their application to real data in tree banking, it's not surprising that the Tetrameric Layer is kind of family jewels for us. However, it's not sitting in the strong rooms of the faculty, it's in active use in our MT systems. TectoMT follows the analysis transfer synthesis pipeline, with layers defined in terms of the FGD theory. Analytic layer for the surface syntax and tectogrammatic layer for the deep syntax. This is the web frontend for the Tweaks processing platform, a generic platform for various language processing tasks. Various applications have been implemented in Tweaks, including an experimental dialogue system. Let's look at TectoMT, the machine translation system in Tweaks. We see that in practice, the process is not as simple. It's actually about 100 blocks that take the input sentence and gradually transfer it to the target string. Let's translate the sentence, "Peter should be at home," to illustrate how TectoMT translates the English verb with all its belongings. Back at our schema, we can focus on the trees. In the source surface syntactic tree, we see that every word has a node. So here is a node for the preposition at, and here is a node for the verb to be, and the modal is a separate node. On the deep syntactic level of representation, the whole predicate, the should be, is represented as one single node in both languages. So actually, the English deep syntactic tree and the Czech syntactic tree on this tectogrammatic layer are identical. This assumption of the tree isomorphism at the tectogrammatic layer lies at the heart of TectoMT these days, and it causes only about 8% of translation errors. The majority of errors are actually caused by the analysis pipeline. A probabilistic translation dictionary extracted automatically from parallel corpus is used to relabel the nodes. So instead of English labels, we will have the Czech labels here. Home will be translated as doma, and to be will be translated as by měl být. All the various attributes, such as the modality should, are handled separately as attributes of these nodes. Given the target side Czech deep syntactic tree, the procedure continues with generation of all the auxiliaries as necessary to reflect the attributes of the tectogrammatic nodes, and in putting the words in particular order, and finally inflecting them as necessary for the sentence. So we see that while the surface form of the sentences was slightly different, which is reflected in different shapes of the surface syntactic trees, the tectogrammatic layer is abstract enough and makes the representations much more similar. Another big advantage that TectoMT has over a phrase-based system is the fact that it can generate new word forms of known words. This generation pipeline and the inflection on the target side is independent of the transfer and independent of the data. It's not limited by the word forms that we have seen in our training corpora. And finally, the tectogrammatic layer is ready for fancy features such as pronoun resolution or other advanced topics not handled by machine translation systems today. The complex pipeline of analysis, transfer, and synthesis is bound to accumulate many errors. So TectoMT on its own does not perform particularly well. But if we combine it with a phrase-based system, we do get a significant boost in translation quality. And that happens despite the phrase-based system is already based on very large data. So that was it. A brief description of theories of deep syntax, but including their practical application in machine translation today.